So this is going to be chapters 7 through 12, basically a brief summary of each chapter. So chapter 7 is network architecture. So it starts off by saying unmanaged switch, which is a switch that provides plug and play simplicity, and this has very little configuration options, and it also typically has no IP address. Managed switches. These are switches that can be configured using a command line interface or a GUI interface. These are usually assigned IP addresses. And then there's layer 3 switches and layer 4 switches. The layer 3 switches are capable of interpreting layer 3 data, and this works like a router. This option is less expensive, and they work great for local area networks. Layer 4 switches, these are capable of interpreting layer 4 data, and these can operate anywhere from layer 4 to layer 7. So when it comes to preventing attacks, these are options for disabling switch ports. So there is administrative down, which this is when a port is disabled by an administrator or in response to an admin's configuration. The port won't receive or transmit data when there is an administrative down until the status is changed. There is also error disables, which this is when the port is automatically shut down due to a problem, and there's many problems that can occur, such as loopback error, duplex mismatch, and many more. Suspended is when the port configuration is experiencing compatibility issues with other ports. So chapter 8 is network segmentation. Segmentation is basically when a network is broken into smaller networks, and each network becomes its own broadcast domain. So some benefits of this is it enhances security, and it'll be much more difficult for hackers to reach protected networks when there's so many smaller networks they have to go through. It increases performance because, like I said, it breaks down the networks, and this will make it for a faster and smoother bandwidth. It also simplifies troubleshooting because rather than examining the entire network, you can look at the smaller networks to find the problems within it. So this chapter also talks about VLANs. VLANs are divided. They divide a physical network into multiple virtual networks. Each of these networks behaves as a separate broadcast domain. These enhance security, performance, and manageability. They're usually configured on managed switches, and each port operates on one of two modes. There's access port and trunk port. Access port connects end devices, and it carries traffic for one VLAN. Trunk port connects switches or routers. These can be used for multiple VLANs. So chapter 9 is about wide area networking, which there is typically referred to as WAN. So WAN can traverse from long ranges as opposed to local area networks. Broadband is great for residential customers, and the cables and available bandwidth are shared between multiple customers. This type of bandwidth is asymmetrical, which means the download speeds are usually faster than upload speeds. There's also dedicated internet access, or DIA. This is the cable itself or a portion of it. Its available bandwidth is dedicated to a single customer. So this is better for business customers, and the bandwidth is symmetrical, which means the upload and download speeds are similar in speed. And then VPN, or virtual private networks, VPN secures traffic by establishing a tunnel for encryption transmission, and it also can increase performance. So troubleshooting WAN connections, there's DNS issue, which you must have the correct DNS information in order to establish a WAN connection. You must also have a functioning DNS server. If you don't have both of these, you cannot establish a connection. There's also router misconfiguration, which incorrect routes in routing tables can result in lost, dropped, or lost messages, and it will not give you an error feedback. And then there's roaming misconfiguration, which this can prevent a mobile device from connecting to networks as it travels throughout the networks. So chapter 10 is all about risk management. Risk management is extremely important because, especially in today's day and age where there's so many hackers, data breaches, spoofing, malware, ransomware, these are all very, very active and very prevalent in our world today. So risk management is extremely important. So there's 3 types of hackers. There's white hat, black hat, and gray hat. So white hat hackers are also referred to as ethical hackers. These are usually IT experts, and they're hired by organizations to assess a company's security and risks. So these are people that are basically hired to hack into your system in order to find vulnerabilities and help you patch those. There's black hat hackers, which these are a group or individual who bypass security with bad intentions. So they have intentions to harm, steal information with malware, and they can use ransomware. And then there's gray hat hackers. These are a group of individuals who go by their own ethics. So they also bypass security, but they don't really necessarily steal or harm. They can do this just for their own fun, for their own amusement, or for game. So they don't typically use ransomware. They just hack in to hack in, basically. And then there's also zero-day exploits, which these are exploits or vulnerabilities that have not been made public yet. So when a new exploit is found, it is considered a zero-day exploit until it has a patch. So there are multiple types of attacks. So the first one is denial of service, or a DOS. This occurs when a legitimate user is unable to access a network because of an attack. So most of the time, this occurs when there's a flooding of the system with so many requests that it can't keep up, and this causes the system to crash. Usually in denial of service attacks, there can be millions and millions of requests per second, and your network just can't keep up with that, so it has to crash. There's also distributed DOS attacks, or DDoS, and these are from many sources. So a denial of service is usually from one source. Distributed DOS is from many sources. So it uses many machines, and the machines are zombies. So what zombie means is the owner is not aware that their machine is being used for an attack. And on these machines, there is malware called a bot that is installed on each machine. So distributed reflected DOS, or DRDOS, these attacks bounce off uninfected machines. And after that, it is reflected or redirected onto the actual target. So for distributed attacks, all the machines that it bounces off of are infected and used as zombies. For the DRDOS, it bounces off machines that aren't actually infected. And then there's also amplified DRDOS. And so distributed reflected DOS attacks can be amplified by conducting small, simple requests that trigger very large responses. So this will also cause the network to crash. So chapter 11 is about access control. As you probably know, security policies are very important. These assess your goals, risks, level of authority, and everything for all team members. These are usually written policies that you are made aware of as soon as you start your job. And you have to abide by these policies. And then obviously if you don't abide by these, this could lead to punishment or even termination. So BYOA, or bring your own application. This is when employees or students supply their choice of software on a computer or mobile device. BYOC is bring your own cloud, and this is when employees or students supply their choice of cloud application or storage. BYOT, or bring your own technology, it's basically a generic reference that includes the other BYO options. And CYOD is choose your own device. Employees or students are allowed to choose a device from a limited number of options. These are usually supplied by the company or school. So depending on which BYO you have, these are going to trigger other policies. So your policies are going to depend on which BYO you have, because each BYO comes with its own risks and vulnerabilities. So acceptable use policy, or AUP, this basically explains to users what they can and cannot do while in network resources. It also usually explains the penalties for violating the terms of the AUP. So physical prevention methods. Physical prevention methods are also important. It's a great way to prevent unauthorized access into a physical place that you have storage. So there's many ways you can have these physical prevention methods. One is keypads or cipher locks. This basically requires an entry code to unlock. So it would basically be like a door with a code, and you would have to type the code to unlock the door. There's also access badge. This identifies a person by name. It could have a photo, a title, and any other information, and this is in badge form usually. So it's something like you'd have to scan your badge to open the door. Biometrics. This scans a person for individual characteristics. It can be fingerprints, your retina scans, voice activations, palm scans. These are very good, but it is expensive to implement into your building. There's also access control vestibules. This is basically an area where you have to go through two doors. Once you go through the first door, the door will close behind you and usually lock. And the door behind you has to shut before you go into the next door. This can prevent like piggybacking and stuff like that. Also, locking racks and cabinets is also important because it's easy for anybody without authorized access to get in. And then you can have smart lockers, which stores all your equipment, and it can only be unlocked after authorization. So chapter 12 is performance and recovery. There's a ton of things that you look out for that could affect your reliability, stuff you might not always think about. So your device rack or room temperature plus the humidity can actually improve your performance or very severely dampen your performance. Flooding, obviously, if there is any flooding, that could destroy any equipment. Smoke or fire, same thing, that could destroy your equipment. Airflow, you need to have airflow to your equipment because this can prevent overheating. Vibration, like too much vibration can knock wires loose. Motion sensors, basically just watching out for people that shouldn't be in the room. Room lights, same thing. If you have cameras, having lights can help you. If you don't have any lights, somebody can sneak in there when the cameras won't pick them up. And your door should always be closed and locked. And then power, you need to have a power source because if your power knocks off, that can really screw up your reliability. So bandwidth management is the collection of strategies to optimize the volume of traffic a network can support. So there's flow control, which configures interfaces and protocols to balance permitted traffic volume. Congestion control adjusts the way network devices respond to indications of network performance issues caused by traffic congestion. There's also quality of service, which prioritizes some traffic over other traffic, so the most important traffic gets through when there is congestion. And disaster planning is very important because disasters happen, so your company needs to have a plan in order to restore after a disaster might happen.